Subscribe Brainwiz and press the bell icon for more updates.
Hi students, I am Pavan Jaiswal, the director of Brainwiz. Now, I'm going to tell you one question from Permutation Combination. This question which is there is repeated in E-Litmus examination. Many students have a doubt, so where we can find out the E-Litmus questions. Don't worry, Brainwiz is a destination where you can just try to subscribe our channel and you'll be getting more and more updates on E-Litmus questions. So this is one such question which have been repeated. Let's try to say you all know that basic knowledge of permutation, that we need to arrange this stuff, and combinations means nothing but selection. Let's try to see the question here on the screen. The question says, how many 6-digit numbers can be formed using the digits 1, 2, 3, 4, 5 and 6? Condition is that you should not repeat without repetition, such that the number whatever you form is divisible by the digit which comes in the units place. Okay, so here let's try to talk about 6 digits have been given to you and we are supposed to find out how many 6-digit numbers can be formed. And you all know that repetition is not allowed. 6 people, 6 places, we can say answer is 6 factorial, the answer is 720. We think answer is 720, the fourth option, but that is wrong. Here he has given you one condition. You can see the screen that the question says that whatever the number you form, that number must be divisible by the number which is there in the last digit, that is the units digit. So suppose for example here 1 sits, so the whole number should be divisible by 1. Suppose here 2 sits, the whole number whichever is formed ending with 2 should be divisible by 2. So like this, how many numbers we can derive? Okay, let's try to see this question now. For this, you should have a basic divisibility knowledge. I think divisibility of 1, the number, every number is divisible by 1. Divisible by 2, you can also say that the last digit you have to check. If the last digit is 0, 2, 4, 6, 8, then the number is divisible by 2. Then divisible by 3, if you see the screen that sum of all the digits, if sum of all the digits is divisible by 3, then the number is divisible by 3. Divisible by 4, the last 2 digits you are supposed to concentrate. If the last 2 digits are divisible by 4, then the number is divisible by 4. Divisibility of 5, you know, this is very basic. The last digit you see either it is 0 or 5, then it's okay. Divisible by 6 is one such thing. Here, whenever divisible by 6 comes, the number should be divisible by 2 and also 3. So having this knowledge of divisibility, let's try to see here. The first case, the number is ending with 1. So we have to find out how many numbers are ending with 1. So when 1 sat here, you tell me how many people are still pending, that is these 5. These 5 people can sit in these 5 places, that is 5 factorial. So we can say that 120 numbers are formed, students, which are ending with 1. Now, let me just try to ask you one small question that if I put this 2, 3, 4, 5, 6, this is one such number in this 120. But if you just look at this number, do you think that this number is divisible by 1? Yes, every number is divisible by 1. So we can say that these all 120 numbers which are ending with 1 is also divisible by the digit which is there in the 1. I think you're understanding, right? Now, let's try to see the second case. In this second case which we are doing now, the number is ending with 2. Now if 2 is sitting here, let me check how many numbers are ending with 2. That is, if 2 sat here, if 2 is already used, now how many people are left? There are 5 people. These 5 people have to be sit in these 5 places, that is 5 factorial. That is 120 numbers. So if you see that these 5 people, 5 places, 120 numbers. So in these all 120, they are ending with 2. For example, let me just write down one number, 3, 1, 5, 6, 4. This number is ending with 2 and also divisible by 2. Now you change these numbers and just try to create one more number, 3, 5, 1, and you say 5, 3, 1, 462. If it is ending with 2 and it's also divisible by 2. So all the numbers which are forming with 2 are 120, and all the numbers naturally divisible by 2 because the last digit is 2. Now let's try to see the third case. The number is ending with 3. Naturally, once again, if 3 sits here, again 5 people are still standing, 5 places are still there. So we can say that 5 factorial, that is 120 numbers. Now are these 120 numbers are divisible by 3? We have to concentrate on that. Okay, now let me just try to teach one number, that is 1 2 here, 4 5 6 ending with 3. So divisible by 3, as I already told, the condition is what? Sum of all the digits must be divisible by 3. Let me add all the digits. 1 plus 2 plus 4 is 7, 7 plus 5 12, 12 plus 6 18, 18 plus 3 21. Yes, it's good. Sum of all the numbers is 21, and you all know that 21 is divisible by 3, then this number is also divisible by 3. So like this, all the numbers which are ending with 3 are 120, and all these numbers are divisible by 3, no matter how much you are changing the people. If you just try to have these digits interchange, here is 5, here is 1, here is 4, here is 3, sum remains constant. How many arrangements are possible, that doesn't matter. All the numbers are divisible by 3 as well. I think you're understanding, right? Now, so let's try to see the fourth case. Dear students, we are at the end of the condition divisible by 4. Okay, so we are supposed to find out how many numbers are ending with divisible by 4. Okay, so we can think that 5 factorial 120, but be careful, this 120 is not applicable because the number which are ending with 4 is this, but the number must be divisible by 4. That you have to check, not the last digit, you have to check last 2 digits. So be careful here. So we should not see the last digit, we have to see the last 2 digits. So the number is ending with 4 and should also be divisible by 4. It doesn't mean that the 4 should be at the end. You can have to see the last 2 digits. It can be 1 2, but 1 2 is not possible. 2 4, yes, this is possible. 3 4 is not possible. 4 4 we are not taking because digits are not repeated. 5 4 is not possible, but 6 4 is possible. In the case of 4, you don't have one, you have 2 cases. It can be either 24 or it can be either 64. So there are 2 cases are there ending with 4, and there are 2 cases divisible by 4. So let's try to talk about the first case here. Now let's try to talk about 24. 24 are already being taken. Now how many people are pending? That is 4. These 4 digits can be repeated in these 4 places. I think you're understanding that. That is 4 factorial, that is 24 numbers. These 24 numbers are ending with 24 and they are divisible by 4. Understood reason? The reason is what? Here the divisibility of 3, last digit you are supposed to check. The divisibility of 2, the last digit you are supposed to check, but divisible by 4, not last 2 digits. So last 2 digits are constant. Rest of all the permutations are 24, and all these 24 numbers will be definitely divisible by 4 because last 2 digits we are concentrating. Now same fashion here, last 2 digits are 64. Again 4 people who are standing here, 6 and 4 are already sat here. The digits which are pending is 1 2 3 and 5. These 4 are arranged in 4 factorial, that is 24. I think you're understanding now. All these 24 numbers are divisible by 4 also. The reason behind the last 2 digits we have to concentrate. Now let's try to see divisibility of 5. So if the number is ending with 5, how many numbers are formed? Let me check. This 5 is sitting here. Then these are the 5 people pending. Leaving these 5, these all 5 people are pending. These 5 places are there. That is 5 factorial. That is 120. So do you think that these all 120? So do you think these 120 numbers are divisible by 5? Yes, naturally, because we have to see only one thing. The number, if it should be divisible by 5, we have to consider the last digit. And the last digit is already 5. So all the numbers which are there will be divisible. Now let's try to put 6 here. How many numbers are ending with 6? Let me find out first. When 6 is going to stay in the last place, 5 factorial, that is 120 numbers. These 120 numbers are definitely divisible by 6. Because divisibility of 6, we have to check divisibility of 2 and divisible by 3. I'll tell you how. Chaliye, let's try to see the divisibility of 2. Do you think any number which is ending with 6, for example, let me just try to tell you here, 2, 3, 1, 5, 4. Let's try to see these 5 people are sitting here. Do you think that this number is divisible by 2? Yes, because we are supposed to see the last digit, that is 6. Now, divisibility of 3 also. For divisibility of 3, you are supposed to see the sum. If you add all these things, 2 plus 3, 5, 5 plus 1, 6, 6 plus 5, that is 11. That is plus 4, that is 15, plus 6, 21. If you add all these people, the sum is 21. So this number is also divisible by 3. And this number is also divisible by 2. And therefore, this number is completely divisible by 6. So when you see, all these cases are there in which the numbers are ending with the numbers which are given and also divisible by the same digits. Okay, so let me add all these things. 120, 120, 240 plus 360, 360, 480, then this is 600. 600 plus 24, 24, 648 numbers are those numbers which are divisible by the digit in its units place. So in E-Litmus, they will give a little bit complex question. Now we have seen the divisibility of what? Such a thing. But sometimes they will say you divisibility of 15, or sometimes they'll give you divisibility of 8. So these all questions we will discuss in our upcoming videos. Divisibility of 15, I should teach you the number system concept, the divisibility, and divisibility of 8 also I should tell you all these things. For these all questions, you have to stay connected with us and you have to download our channel. Okay, so you have to download our app and also log in to our website. And also you can just try to watch all these questions on our YouTube channel, Brainwiz, and also press the bell icon. Thank you.
Think placements, think Brainwiz.